Hi there. Let's do the organic reactions introduction. Addition to pi bonds and substitution of hydrogens, the sigma bonds, and then the free radical reactions, and also condensation, the esterification, and then polymerization finally. Now we want to look at first the covalent bonds of carbon could be a little bit different because they can be hydrogen, they can be X, the electronegative atoms, also similar to hydrogen, the E, the electrophiles, right? Now, if you have electronegative X's, it's going to take the both electrons and it'll make X minus, that is also called the nucleophile, something like bromide, right? And then look at the hydrogen. Hydrogen gonna dump the electrons on to the carbon and it'll become H plus, and then the E also going to drop the both electrons onto the carbon and E plus, and as a result nucleophile and carbocation is produced on your left, and electrophile or proton plus carbanion is produced in your right. So these arrows are very important, and also the names. Now look at the down one. This one is hydrogen can homolize. That means you cut in the middle the bond and each carbon and hydrogen gets each electron. These are called the free radicals. These are very reactive and they will show special radical reactions. In this case you make a methyl radical. Okay, now first one we're going to talk about the simple one, the combustion. You all know about it. So the fuel, the hydrocarbons combust in oxygen, it'll generate heat. That's how we run our cars, right? So hydrocarbons and oxygen will give you CO2 gas and water liquid and heat generation. Now know how to balance it. So I got propane, oxygen, and 3 CO2 and 4 water, and 4 oxygens for the water, and 3 times 2 6 oxygens for the CO2, total of 10 oxygen atoms. So you need 5 moles of O2, right? Now this is complete combustion, so you need to know how to do it. Now also pay attention to the incomplete combustion. Incomplete combustion happens when you have less oxygen and more hydrocarbons. What do you get? Carbon solid, carbon monoxide, CO2, and water. Now that's also you need to know how to balance it. And then what is extra? Carbon plus solid and carbon monoxide. So that's the incomplete combustion, right? Okay, now we're going to look at now the number 2 reaction, the review of halogenation. So in the halogenation, you are actually substituting hydrogens with halogens. So that means chlorine, fluorine, bromine, iodine, but the mid two are the best, chlorine and bromine. So the two ends are either bromine, iodine is violently reacting, fluorine is violently reacting, and iodine is too sluggish, right? Let's take CH4, the simplest one. X2 is any halogen, and in the presence of UV light, it'll makes you CH3X and HX. Now, if you keep reacting more and more and more X2 is added, you're going to end up with CX4. That's fully halogenated hydrocarbon. And you're going to make some HX, 4 of them, right? So that's the extreme reaction. So you can actually manipulate. If you want CH3X, you're going to get more hydrocarbon. If you need more CX4, you're going to put more halogen. So that's how the chemical engineers actually um, arrange the reactions based on their products. Now look at this one. In the presence of UV light, chlorine, when the UV light saps on it and it's going to break in the middle, that's homolysis. Each electron walks away with each chlorine atom. That makes this radical. Radical is actually an atom, very reactive. So it's chlorine dot basically, that's a radical, free radical, and that will react with the sluggish hydrocarbon. So the chlorine-chlorine bond is weaker, that's why you can homolyze. Now you have radical chlorine, and it will react on the methane. So it will make a methyl radical, CH3 dot, and a HCl neutral molecule, right? Now CH3 dot, the radical will react again with something, right? So this can continue. And these are called the propagation reactions, right? So what happens, this radical, CH3 radical, gonna hit on a neutral molecule, something like chlorine, something like CH4. So it will react, and each electron comes with the half fish hook. That means each partner component giving you one electron, right? So it could be actually CH4 as well, but we'll take something like Cl. So I can show you the first step. Yeah, chlorine also possible if it is available, and it will homolize, and CH3 combine with the Cl, and you leave behind a chlorine radical. Okay, so this one is complete now. So one neutral molecule, CH3Cl, chloromethane, and one chlorine radical. Now, so that's the second reaction. So the third reaction, sorry, that's the third reaction. The fourth reaction is Cl radical reacts with a Cl radical, and it will make a chlorine molecule. That's also possible. And also methyl radical can react and combine and make a ethane as well. Okay. All right. Now here, so when you have neutral chlorine giving you two radicals, that's called the initiation. That's the easiest step. The weakest bond is chlorine to chlorine. That's why. So that's the initiation step. Now, one radical reacts, gives you another radical. That's called the propagation. You see left one radical, right one radical. Same thing next one. One radical left, one radical right. So it's keep moving. So that's a propagation step. So there could be many propagations. The last one, two radicals combine with the half fish hook, and it will make a neutral molecule. That's a termination of radical reaction. So these A, initiation, B, propagation, C, termination, all three together we call the chain reaction. So the chain reactions are typical. You're going to see many chain reactions as we go. Okay. Now hydrocarbons and X2 can give you so many different products depending on the how long we react, how much of halogens we have. Now the third one, addition. Now this one has a lengthy list, but we'll take few examples, right? So addition to the pi bond. In a pi bond, here's a pi bond, right? In a pi bond, there's one sigma and one pi actually. So these are the sigma bonds, all in green. I put it in the sigma bonds. So these are hard to break, but the pi bond, the red one, is easy to break, right? Now, so we put our R group on your right, so it's easy for me to explain how the addition takes place, right? For this top alkene, and we're gonna add an HBr. So the HBr, what happens is the H becomes positive and the Br gets the negative because it's more electronegative electrons, right? It gets the electrons. So the pi bond opens to the proton and the Br hits on the other carbon, and it's kind of like a cycle. And think without the mechanism, just think that way. So what I did across the double bond, hydrogen and the Br added into the pi bond. So that's the simplest way to get your answer in the right side. Now we can do the same thing for the cyclohexene. Now you can add any of something like HBr. In this case, we can, let's see, we can add an E and X, that's electrophile and X. That would be something like HCl, HBr, HI. And it just rotate about, and then the E goes across the double bond and the X goes across the double bond, right? So you get the neutral product. So now what you did, you broke the pi bond and make two sigma bonds, right? Now this breaking the pi bond only, the not the sigma bond, and adding anything EX, right? That could be HCl, that could be HBr, that also could be HOH, that's water. It could be HOR, an alcohol. It could be HI, it's another acid, right? All these things could be chopped in the middle and stick on across the double bond. So that way you should be able to write all 5, 6 different reactions. And in this case, the hydrogen went to the more hydrogens. It's called the Markovnikov's rule. If you can't say it, say Mark's rule. It's actually Markovnikov, one of the Russian chemists, and but simply my students say Mark's rule. That's fine. Okay. Now the pi bond is again broken in the middle. How actually happening here? It's kind of an important thing. Let's take a Br to Br. That's also possible. Actually, let's take something electrophile. That's Br, and in this case, Cl is like delta negative. Right now, the pi bond attacks the electrophile, the Br delta plus, based on the electronegativity.